Hello everyone, I'm Jing from ETH Zurich. I'm very glad to present our work, Musical Features Modification for Less Intrusive Delivery of Popular Notification Sounds. We receive a lot of notifications every day. These notifications effectively connect us with our activity contexts and objects or devices we interact with. However, research has shown that notifications can be a source of distraction and stress. But disabling notifications is not a satisfying solution either, since this will make people unaware of their surrounding activities. This double-edged sword character has motivated some research to deliver auditory notifications in a less intrusive but still effective way. For example, some researchers create ambient soundscapes using specifically designed audio cues, such as a thunderstorm sequence. In recent years, since digital music has become very popular, and many people have the habit of working or conducting other activities over music, some researchers deliver auditory notifications by modifying the music that user is listening to, such as changing the tempo of the music being played. A common feature of these works is that they usually design new audio cues as the notification signal, while little work has focused on the existing notification sounds that are already commonly used on digital devices like iOS or Android systems, or for popular applications like Skype and WeChat. In our work, we aim to deliver these commonly used notification sounds in a less distracting way. We propose a notification delivery method as illustrated in this figure. We first transfer the timbre of a notification sound into the timbre of the music that the user is listening to. During this process, we preserve the original melody of the notification to still associate the notification with its interpretation. Afterwards, we deliver the timbre transformed notification by harmoniously integrating it into the music. To realize this notification delivery method, our work explores two topics: notification timbre transfer and notification integration. Let's first take a look at our notification timbre transfer approach. Several timbre transfer methods have been developed for normal music pieces. However, we see some challenges that differentiate the timbre transfer for notifications from normal music. First, there is insufficient training data of notification sounds in general. Moreover, there is no paired data of notification sounds played with different instruments. This issue largely limits the set of applicable timbre transfer methods. Furthermore, unlike music played with specific instruments, it is difficult to define the timbre of notification sounds since they can be generated in several ways. To tackle those challenges, we propose a melody extraction-based approach. Given an input notification sound, we first apply a pitch estimation model to extract the raw activation matrix of the notification sound. Each entry in this activation matrix represents the probability for a pitch to be active at each time step. This raw activation matrix contains noisy notes that should be removed to obtain the melody of the notification sound. So, to extract a clear melody from monophonic or polyphonic notification sounds, we present a three-step algorithm: note activity detection, polyphonic pitch extraction, and temporal smoothing. We extract the notification melody into its piano roll representation, then we convert it into MIDI data. Afterwards, we conduct timbre transfer by synthesizing the MIDI data into an audio wave with the target instrument that matches the timbre of the background music. Next, let's take a look at our notification integration method. Remember that our goal is to provide a noticeable but not intrusive notification experience. Therefore, we propose the following ideas for the integration. First, the notification sound should be inserted at the change of a melodic segment of the background music, so that we don't break note that is being played in the music. Second, since the notification will replace a part of the background music, the musical feature of the notification sound should be similar to the feature of the music segment that is being replaced. To implement these ideas, we first split the background music into segments. We do this by calculating the self-similarity matrix of the background music. Next, to find the most similar segment that can be replaced by the notification sound, we first modify the amplitude, tempo, and octave band of the notification sound. Then we calculate the similarity between the modified notification sound and each music segment to find the most appropriate insertion spot. Finally, we insert the notification into the background music with fade-in and fade-out effects. Implementation details of our notification delivery method can be found in our paper. Audio samples of our method can be found in the supplementary materials. To investigate users' experience with our notification delivery method, we conducted a concept validation study in a controlled experiment setting. In this study, 32 participants did puzzles with background music. Notifications were delivered either using our method or using the standard method in digital devices, that a notification is delivered in parallel to the background music without any change. Regarding noticeability, both standard and our methods had 192 test cases in total. All the standard notifications were successfully captured, and only 2 participants missed 2 notifications delivered in our method. The missing rates are rather low. Moreover, according to participants' feedback on a 5-point Likert scale, subjectively, they also tended to believe that they successfully captured the notifications delivered in our method. How distracting did the participants experience with these 2 delivery methods? In this work, we focus on their perceptual intrusiveness of the notification delivery. According to their feedback that was collected from several study sessions, they experienced our method less distracting than the standard delivery method. We also acquired many inspiring insights from the participants' feedback. One of the feedback I like to mention here is that sometimes people would like to be clearly notified of very important things. In this case, they accept to be distracted. In other general cases, some participants commented that they would like to use our delivery method if they want to focus on the current work while maintaining awareness of their surrounding activities. We suggest that for the future design of notification systems, users can choose different notification delivery methods for different events on applications to personalize their preference. Or we can develop notification systems that automatically detect the user's state and accommodate the notification delivery approach correspondingly. To conclude our work, first, we explore a novel method to deliver the commonly used artificial notification sounds in a less intrusive but adequately noticeable manner. Second, we develop a melody extraction-based method to change the timbre of arbitrary notification sounds. And we present an algorithm for seamless notification integration into music. Third, we conduct a user study to explore users' experience with our notification delivery method. We also discuss implementations for future work. Our work also indicates several interesting directions for future research. First, our current method only works well for single instrument target timbres. While it is interesting to explore the challenging task of transferring notifications into more complicated music styles that contain multiple timbre tracks. Second, it is interesting to conduct an in-the-wild study to explore the usability of our notification delivery method in users' everyday life. This brings me to the end of this presentation. Thank you very much.
Given the dynamic sonic presentation of the notification, how would users disambiguate notifications from different apps?
I'm not quite sure what he or she means by dynamic sonic presentation. So we assume that like we just focus on the notification sounds that have been very commonly used on digital devices. So one assumption is that users are familiar with the notification sounds they use, and the notifications are associated with the application. Like I guess people are familiar with Skype sounds, with maybe Snapchat, or maybe familiar with WhatsApp sounds. So if that answers the question, like the problem here is not that we want users to use new notification sounds. They should use the original notification sounds they have been used to. It's just like how we deliver this notification sounds in a less distracting way.
Oh, I see. I think that was a misconception because I was also under the impression that you were introducing new content, but you're using the same notification and you introduce it in a seamless manner. That's what you're saying, in a less intrusive manner.
Exactly, yeah.
Okay, the follow up to that, in one of the comments that you had in your user testing, you mentioned this, that some people might want to be interrupted in certain cases versus not. Can you elaborate a bit on that? Because it's interesting. What were the settings that people would want to be interrupted?
Like, for example, we all have the moments in our life we are waiting for an important email, we are waiting for an important message from a friend or a colleague. Like in this case, we want to be clearly notified when the messages came immediately. Like in these cases, we can afford some, some level of intrusiveness. We even want to be distracted by a news. But on the other hand, in most cases, we maybe want to focus on our work. But at the same time, we don't want to be isolated from our activity context. And we still want to get notified, want to be notified of something. We maybe don't check it immediately, but we just want to be notified of it. Like in this case, we want to use some methods that deliver notification less intrusively, like maybe like our method use or other method uses. So probably the future design of notification systems can be like this. So users should have the choice to choose, okay, what kind of notification delivery method I want to use for this kind of application or this kind of event. Or maybe a notification system can be more intelligent, like to discover or to detect the user's state, whether this user wants to be distracted now. Or if the user wants to be distracted, then maybe I can just play the notifications in a very loud way. Or if the user doesn't want to be notified, if the system detect that, and then I just play it quietly or using some tricky methods to do that.
Yeah, I think there is another follow
Yeah,
up.
true. Like Nicholas, the question true. Like if you're waiting for something important, sure, you want to have this intrusiveness. So that's like what I said just now. Sometimes like people want to be notified of some things important very clearly. Like in this case, they probably want to use the normal notification delivery approach.
And there is another question about urgency and importance level of the application.
Well, we didn't really think about, like we thought about maybe our method cannot be used in the super urgent situation for sure, because in the super urgent situation, people want to be notified of the emergency very clearly, but we cannot quantify the importance, also like the importance of application of our method.
Excellent. Thank you very much again, Jing. And
Thank
we
you.
can continue discussing this very interesting application in the Q&A session later on.